we go. As I mentioned, I'm Jenny Erickson. I'm the Senior Director of Enrollment here at the University of Chicago Harris School of Public Policy, and I am delighted that I'm joined today by Assistant Professor Fiona Burlig. She is one of the professors that our students talk about all of the time when they're talking about her classes, and we hear great reviews. Right now, if you visit Harris and you do a campus visit, you can sit in on her program evaluation class. So very lucky that she is joining us today. She studies energy and environmental economics with a focus on the developing world. Her research examines the impacts of rural electrification in India, uses machine learning methods to quantify the effectiveness of energy efficiency upgrades, and proposes tools for designing randomized controlled trials. Before joining Harris, she was a postdoctoral scholar in the Department of Economics and Energy Policy, otherwise known as EPIC at the University of Chicago. Many of you are probably familiar. And she has a PhD in agriculture and resource economics from the University of California, Berkeley, and a BA in economics, political science, and German from Williams College. Professor, handing it over to you.
Great. Thanks so much for having me and for that embarrassingly nice introduction. What I thought I would do today is share with you some of my ongoing research that's being done with a bunch of colleagues here at the Harris School. As Jenny mentioned, I would be more than happy to take questions. I'm not the best at managing Zoom, so the easiest thing for me would be if you guys just unmute yourselves and hop on in if you do have a question. But as she said, if you are unable to do that, feel free to post things in the chat and we will find our way to getting things answered. Okay, great. So this is brand new work. It's so new that you will not find any of the results here on my website. This is really like stuff that's quite in progress, as you'll see. But I thought that that would be kind of fun to share to give you a little bit of a sense of not just things that are finished and published, but like stuff that the Harris faculty are actively doing. This is joint work with a whole host of collaborators. So namely Amir, Gina, and Greg Lane, who are both fellow assistant professors here at the Harris School. Herschel Sehai, who's one of our PhD students in the econ department, and then Aaron Kelly, who's currently at the World Bank, but will be joining us here at Harris next spring as well. So a really kind of big Chicago in-house team that's been super fun to work with. So as Jenny mentioned, sort of a lot of my research is on energy and environmental economics, focused in developing countries. My main kind of geographic area of focus has been India. And so this is a project that is going to take place in India as well. What we're going to be thinking about here is exactly what the title suggests, the value of forecasts. So we're particularly interested in working in agricultural settings to try and find ways to basically help farmers cope with an increasingly variable climate. Okay, so just as a little bit of motivation, and so I can show you this nice picture. My colleague Amir is a fabulous photographer, so this is a photo that he took himself in the field not too long ago. Kind of why do we start on this project in the first place? Well, it turns out that if you're interested in economic development, you sort of have to become interested in agriculture. The agricultural sector is the driving force behind many low-income country economies. And as soon as you become interested in agriculture, it becomes very obvious that there's substantial risk in the agricultural sector, which is of course related to what the weather is doing, right? So if you have a good rainfall year, that can lead to really productive crop output, the ability to produce and sell cash crops and sort of lots of income. If you instead have a really bad rainfall year, that can kind of be devastating in the opposite direction. So a massive fraction of the world's working poor depends on agriculture for their livelihoods, and risk associated with weather in these low-income countries is really substantial, affects basically everybody who's working in this sector, and leads to a bunch of challenges. So one is just in the absence of insurance markets, and we can talk at length about why those insurance markets might be missing, but in the absence of insurance markets, there's a lot of research that suggests that farmers are less likely to invest in profitable input technologies, things like the optimal level of fertilizer that might be useful, but is hard to invest in when you're worried about downside risk. And that contributes to a really large gap in agricultural productivity between wealthy countries and poor countries. So despite the fact that a much larger share of low-income country populations work in ag, the value added per worker in agriculture is actually much lower in low-income countries than it is in high-income countries. And we think a big portion of this is actually due to underinvestment that's related back to that weather risk. So this ends up being a pretty big problem. And we're going to be thinking about these issues in the context of the Indian summer monsoon. So monsoon-fed agriculture is actually really prevalent around the world. Around 33% of the world's population lives in kind of the South Asian monsoon region. So if you care about weather risk in ag, this is an important place to be looking. The way the monsoon works, if you're not familiar, is basically you go from having a dry season to having a rainy season. During that rainy season, it rains quite a lot. So 70% of the year's rainfall happens during these rainy, typically summer months. While that monsoon is essential for the functioning of Indian agriculture, it also has this kind of frustrating feature, which is that it's very variable. So whether the monsoon starts early, starts on time, or starts late is kind of totally up in the air year to year. And it's very hard to predict year over year whether you're going to have an early monsoon, an on-time monsoon, or a late monsoon. That turns out to be really important for agriculture. So the later the monsoon is, you should basically think about that as close to 1-to-1 with the worse the season is going to be. An earlier monsoon start means that you can grow more cash crops. You can even double crop, so grow two things in the same season. If, on the other hand, you're stuck with a really late monsoon, then you tend to be kind of more forced into subsistence style agriculture that provides you with enough crops for you and your family to eat and survive, but not so much that you're going to be able to really sell on the open market. So this map is just showing you some data from kind of the recent history in India, thinking about the mean onset date on the left-hand side here. So the monsoon starts over Kerala and then works its way sort of north and west across the country. And then on the right, maybe more interestingly, sort of the variability in that onset date. So we're going to be working here in the outlined state of Telangana, where the standard deviation of that monsoon onset is quite high. There's really large variability year on year as to when the monsoon is going to start. And that's true today. We expect that to become sort of a bigger and bigger problem with the changing climate to the point where the monsoon is going to be even more difficult to predict, and that onset date is going to start to be even more variable. Okay, so that's kind of the background where we're sitting in. Now, as soon as you start talking about risk, any economist will tell you we have a great solution to helping people deal with risk, which is insurance, right? And while it's the case that insurance markets are pretty thick and pretty common in wealthy countries, insurance tends to be kind of challenging in these low-income settings. So there's a lot of research, and this plot here on the right is from a paper that studies insurance in this context. There's a lot of research that shows basically two things. The first one is that if you can get farmers to actually adopt insurance, that insurance tends to be quite useful for them. They use it to cope against these big weather-related risks and invest in profitable technologies. So yes, insurance does seem to be doing what we'd like it to do. The downside that's been shown across multiple studies in many different contexts is getting those farmers to actually adopt that insurance is quite difficult. So the graph that I'm showing you here is looking at take up as you, no, Siri, I don't want to talk to you. Sorry, it's looking at take up as you vary the price of insurance. And in particular, what this shows is that it takes really large discounts from an actuarially fair or sort of like even price of insurance to get people to actually take that insurance up. And there's sensible reasons for this, right? If you're thinking about insurance in a low-income country context, you're probably working in a setting where there's fairly low contract enforcement. What that means is, okay, what is an insurance product? An insurance product is someone comes and knocks on your door and says, hey, if you pay me $100 today, I'll return to you with $500 if it turns out to be a really bad year. That's all well and good, and we're used to the system. But if you're in a world where it's very likely that that guy will take your money and never show up again, and you have no legal recourse, you're pretty unlikely to actually follow through with making that payment, right? Making that investment. So insurance is really attractive if you can get people to buy it, but getting people to buy it is difficult for various reasons. Another solution that people have tried to embark upon is new technology in the form of flood or drought tolerant seeds. Again, this can be really useful. So the way that these seeds work is that they're specially bred such that it's typically rice. If you happen to have a flood year, the rice crop will do just as well as if you have a normal rainfall year. That's great because it means it guards against the downside risk of having a flood year. That's sort of the flood tolerant version. There's also drought tolerant versions which work the same way, but on the other side. The downside of this is that it really locks you into one particular crop. So the crop breeders have gotten really good at flood and drought tolerant rice, but we don't yet have things like flood and drought tolerant chilies or cotton or turmeric or the other kind of more prominent cash crops in these regions. And so, yes, you have this kind of useful adaptation technology for the main staple crop, but not so much for these other cash crops. And we would love to give farmers a little bit more flexibility with what we're able to grow. So that's where we come in. What we're going to do in this project is provide farmers with what we're going to call long-range monsoon forecasts. So unlike the weather forecast that like we all have on our phones, right, that tell me like today in Chicago is actually going to be really beautiful. The forecasts we're thinking about in this project are telling you information about 6 to 8 weeks in advance. And the information that they're going to tell you is when exactly is that summer monsoon going to arrive. Okay, so what this is going to say is something like the summer monsoon is going to start on June 16th, plus or minus 4 or 5 days. Okay, and the thing that's cool about that information is that that's informative about things that are relevant to the entire growing season, not just is tomorrow going to be hot or cold. And by giving that information pretty far in advance, it hopefully gives farmers the opportunity to make lots of adjustments. So what kind of adjustments might farmers be able to make if they know what the weather is going to be a month or two beforehand? What they can do is things like ordering new seeds. So if you want to grow cash crops, that's great, but it's probably the case that the local agricultural vendor in your village doesn't have a ton of cotton seeds available. They need to order them from the bigger market town. That can take a little while to come in. Another thing you might want to order is fertilizer. Again, there's going to be some of that local to you, but not all that much. You can also coordinate labor. So if you'd like people to all be working in your field at the same time, you know when you're going to plant, you can hire a bunch of people in advance to have them come and work on the field. On the other hand, if you get information that this is likely to be a bad year, and rather than being able to grow cash crops, you're going to be really stuck doing subsistence agriculture, having information about that early on can give you another option, which is potentially the ability to do things like migrate out of the growing area and into the city instead. And giving you some lead time allows you to potentially rent your land out and make arrangements for yourself to go to the city rather than sort of sitting around and waiting for the rain to actually start. You can get ahead on kind of earnings in the urban setting. And these forecasts, we think of potential promise in this region for a couple of reasons. The first one is we've done a lot of work talking to farmers and trying to understand what they know about what the weather is going to do. And it turns out to be the case that farmers actually know quite a lot. If you ask them information about the historical distribution of when the monsoon has arrived in the past 10 years or so, on average, they're basically about right. So farmers are aware of what's going on. The rainfall is really important for their ability to earn a living. And so, of course, this is something you would expect them to be aware of. But while it's the case that they know a lot about what's happened recently, they're pretty bad at, and for reasonable reasons, pretty bad at predicting what's going to happen this year. Just like if I ask you, is it going to rain a week from now or not? You might be able to give me some idea because it's the spring and you know where you live, but like knowing exactly is really difficult. This is actually a much harder forecasting problem than even that would be. The other thing that's nice about these forecasts is, especially compared to insurance, which requires like a large system of banks and other things, or flood or drought tolerant seeds that also require sort of a large distribution network for those seeds, forecasts could potentially be delivered at really low costs. We're in a world where almost every farmer has at least kind of a dumb Nokia brick phone. Some of them have smartphones now. But what that means is giving people a phone call or sending people an SMS saying, here's when the monsoon is going to arrive, is a really, really low cost thing to do. Okay, and so that brings this technology, the cost of this technology really far down. And so you can imagine sort of cost benefit ratio looking pretty good. Okay, so those are kind of the main things I wanted to say about the general setup here. Does anybody have questions before we dive in a little further to what we're actually doing?
Yeah, I had a quick one.
Yeah.
So you mentioned that you picked this particular region because of high variability. Is there any particular reason why this specific one, there seemed to be several that had high variability on the onset of monsoons.
Totally. So there's a couple of reasons. One is that there's high variability of the monsoon onset. The other one is that the forecast product we're going to be working with is brand new and was sort of first developed in this particular region. So we know that it works really well in this setting. The group of scientists that's doing the forecasting is working to expand the area where the forecast works. But this is kind of the first test bed where they tried it out. And so it's a useful place for us to work as well. Great. I think I saw another hand.
Abdul, yes, I think I see Abdul's hand. Abdul? Professor, we did get a question in the chat. Abdul, if you aren't able to unmute and you want to send it into the chat, but another one that snuck in, what are the other financial risks associated with the agricultural risk besides price risk from Henry?
Yeah, so price risk is one piece of this. The other big piece is actually just like output risk, right? So if you've planted a bunch of cotton and then it doesn't rain nearly enough, your cotton crops are all going to die. And so regardless of what's going on with the price, you just have nothing to bring to the market. So those are kind of two things that go together. Yeah, I'd say, Abdul, if you have a question, if you want to go ahead and post it in the chat. I see you're unmuted, but I also don't hear you. So okay, I'm going to keep going, but if you do have a question, feel free to jump in. All right, so the kind of big innovation that we're relying on here is something that is not our own. So nobody on the team is a climate scientist. We're all sort of econ and econ adjacent, which means that we steal shamelessly from other people. Now we're giving them giving them credit here. The forecast that we're using is developed by researchers at PIC, the Potsdam Institute for Climate Impact Research. This forecast is kind of, as I've been alluding to, an onset forecast. So it tells you when the monsoon is going to arrive. It is particularly useful over Telangana and other Indian agricultural regions. It's been correct 10 out of the last 10 years. And in fact, if you kind of do some exercises where you check the validity of that model, backcasting much further, it tends to be right about 75 to 80% of the time. So it's a pretty good forecast. And it's issued sort of again in this kind of 4 to 6 week period in advance of the monsoon's onset. So that's the brand new technology we're bringing into this space. There is an existing forecast, so it's not the case that farmers have absolutely zero information. The Indian government actually hands out forecasting information of a couple of different types. So one piece of information that the government hands out is a monsoon onset forecast. Now, that onset forecast is a little bit different from the one that we're looking at in a couple of key ways. So the first one is that the location over which the India government is producing this forecast is Kerala. So if you remember that sort of shape of India, we're working kind of up here in like the breadbasket of the country, but the Indian government forecast is over Kerala, which is where the monsoon first arrives. So the reason they want to do that forecast there is because that's where it first comes to the country. The thing that's kind of unfortunate about that is it turns out that when the monsoon arrives over Kerala has a very, very low correlation with when the monsoon is actually going to reach other parts of the country. So it's not enough if you're a farmer to know, hey, the monsoon has hit Kerala. That's not going to tell you uniformly 2 weeks from now it's going to hit me. There's massive variability in that. So that's kind of one downside. The other big downside is that the forecast that the Indian government is providing is issued only 2 weeks in advance. And so that gives farmers less ability to be flexible about their early input decisions. The government does, in fact, provide another type of forecast, which is instead of being an onset timing forecast, it's a quantity forecast. So how much rain is going to fall over different parts of India. That might be super useful, except it turns out that it is not actually useful in practice. The information that's provided by that forecast has been shown to be uncorrelated basically entirely with actual rainfall realizations. And it turns out the farmers know this as well. Farmers have realized that this forecast isn't providing useful information and therefore don't actually respond to that information. So we think that the product that we're borrowing from PIC is a substantial improvement over this existing forecast. And we have good reason to believe that the farmers don't actually have access to this PIC forecast. Of course, if we were working with like really large agricultural cooperatives or kind of major producers, you might imagine that they would be investing a lot of money into trying to get good forecasts. Farmers in the US spend tens or $20,000 a year at a minimum in trying to get good weather forecasting information. The farmers that we're going to be working with here are primarily smallholder farmers, so sort of median about a hectare of land each. So these are just people that are not really going to have access to this kind of new forecast. It actually turns out to be like kind of hard to find it unless you know specifically what you're looking for online. So this isn't something that's sort of widely available already. Okay, so what are we trying to do in this project? We are going to ask basically the straightforward question that you might think to ask in this setting, which is what are the causal impacts of long-range monsoon forecasts for farmers? We're going to ask a kind of series of sub-questions, some of which I'll show you a little bit of evidence on today, some of which I'll skip for time. So the first question that we're going to ask is how do these forecasts actually affect farmer belief? You can think about that as a kind of a key step here, because if I go ahead and tell you forecast information and you ignore me entirely, you shouldn't expect any downstream impacts, right? So the first thing we need to do is provide information to farmers that they actually listen to, and we'll talk about how we actually do that in a second. We elicit some information about willingness to pay for forecasts among the farmers. I think I've taken that mostly out of this, but spoiler alert, these seem to be something that farmers are actually willing to pay for. Thirdly, we're going to ask kind of how farmers actually respond to the forecast in terms of their agricultural practices. The main things we're interested in are their ex-ante inputs, so how much fertilizer they're using, how much land they're cultivating, how much labor they're hiring, that kind of thing. We're also going to look then at what happens after the growing season. So you have both the forecast information and then the weather realization has happened. And there we're going to be able to look at kind of ex post ag outcomes, as well as some metrics of welfare, things like consumption, things like that. And we also are interested in comparing these effects to an index insurance product, which is kind of the canonical risk mitigation tool, right? So we want to go beyond just evaluating the impacts of the forecast and think about how this might compare to something else that people have tried in the past. We're going to use a randomized trial to study these questions. What I'm showing you today is results from the first year. The second year is in the field, like right now, they're currently doing the baseline survey. So the call that I was on just before this was with some of our field staff kind of monitoring how that survey is going. So once we're done with the second year, we'll also be able to tell you some things about how does the farmer respond to the forecast after being exposed to it for 1 year, right? So you might imagine that this is a brand new technology that's giving you information. Maybe I trust it to some extent, but I'm not totally willing to adjust everything in response to information that I get for the first time. What we're going to be able to do in the second year is provide farmers with that information again and see if they're more responsive after they've had experience with the forecast once. And that's important for thinking about rolling this out at scale. Okay, so for today, we're only going to show you stuff from the first year, but eventually we'll get to being able to say things about year 2 as well. Okay, questions there before we show you exactly how we're doing this? Okay. So because this is an econ paper, we start with a little toy theoretical model. Okay. I like pictures more than math, so I'm going to show you the model in pictures rather than in math. Okay. So what this is showing is what a forecast should do to a farmer's investment. Okay. And so the background here is a very simple model in which the better a rainfall realization is, the better a year it's going to be, the more you should invest in your land. Okay, so that's the idea that like you can think about the investment, if you like, as being fertilizer or cash crops. If it's going to be a really good year, you should go all in. If it's going to be a really bad year, you actually kind of want to pull out of agriculture. Okay, so that's kind of the underlying dynamics of the model. This middle blue line shows what you should do as a farmer in terms of inputs, depending on how likely you think it is that it's going to be a good year. So if you're down here to the left, you think it's really unlikely that this is a good year, it's going to be a really bad year, you should invest very little. If you're all the way over here to the right, you think it's very likely that it is going to be a good year, then you should be investing a lot. Okay, so that's kind of the baseline. But now what we're doing is adding in information about the forecast. So if we tell you the forecast shows you good news, it's going to be a better year than you maybe thought, then you should start doing those investments earlier. Whereas if we tell you that it's going to be a bad year, you want to actually delay those investments. Okay, so the important thing here is we get a split in what farmers should be doing based on what they think happened to begin with. So if you get good news, you should do more investment. If you get bad news, you should do less investment. Okay, so that's kind of the basic result of the model about the forecast. We can also kind of use the same model to think about what might happen with insurance. With insurance, things look a little bit different. And basically everybody should be investing a little bit earlier, doing more investment. That's consistent with like a bunch of kind of previous work on insurance. And the basic intuition is just insurance gives you protection against downside risk. So regardless of whether you think it's going to be a really bad year or a really good year, you have some leeway to try things out and go ahead and attempt those investments, because if it turns out that it's a better year than you thought, then those investments will really pay off and you don't have to worry so much about it turning out to be a bad year because you get a payout in the bad state of the world. Okay, so the forecast and the insurance have these two different predictions. The forecast prediction is that whether you should do more or do less depends on whether you get good news or bad news. The insurance kind of for everybody should push you into doing a bit more, okay? Models are fun, but even more fun is actually doing stuff in the real world. So what we're going to do to test the impacts of the forecast is, like I said, run a cluster randomized trial. So what that means is that we have come up with a sample of 250 villages that are largely sort of unirrigated and in southern Telangana. And we've randomly divided these villages into 3 groups. We have 100 of these villages that are the control group. We're going to do only surveys, but no intervention with these folks, okay? Then we have 100 villages that are getting offers of the forecast. You can think about that in practice as basically getting the forecast. There's like some detail there that we won't have time to go into here. And then there are 50 villages that are getting access to this insurance product. Okay, and so what's nice about doing this in a randomized way is that we can be sure that any differences we see in the end line or in any of our surveys are driven only by the forecast or only by insurance, not due to other differences between these villages kind of in the underlying state of the world, right? So if you were to just compare a village that was where lots of people were buying insurance on their own to a village where lots of people weren't buying insurance on their own, in the absence of an experiment, you might be concerned that the places that were buying insurance were wealthier or better farmers or better informed or had more access to technology, things like that. And so it would be really difficult to interpret that difference as the causal effect of insurance. Here we can be very clear that what we are getting is the causal effect of our forecast or the causal effect of insurance, because we started off with a population and then randomly split it into these 3 different groups. Within these villages, we're then going to interact with about 5 or 10 farmers per village. We would have loved to do more, but it turns out to be pretty expensive to run a project like this. So we're limited in our total sample size. But for every farmer that we interact with within one of these villages, we sort of treat them the same way. So all of the farmers in the control group villages, we just do surveys with. All of the farmers that we interact with in a forecast village will get the forecast from us, and all of the farmers within an insurance village will get the insurance from us. So the comparison we're going to be making here is between a control village and a forecast village, not between an insurance farmer in an insurance village and a control farmer in an insurance village. Okay, so everyone in the insurance village is going to get that insurance. Does that make sense? Okay. Great. One important thing I want to point out here is that we're working, of course, not just on our own as the UChicago team, but we're implementing this with a kind of very well-known international organization called ICRSAT. ICRSAT is, you can think about it as basically a giant agricultural extension office based out of Hyderabad, so in the state that we're working in. They're really well known in the area, and they provide farmers with all sorts of different advice about how to actually grow their crops and sort of do as best as possible. They also conduct a lot of research. And so it's valuable for us to partner with them because the farmers basically have a lot of experience with ICRSAT. And so this is going to be information and insurance products coming from a pretty trustworthy source to begin with. That's useful because if I just show up and I'm like, hi, I'd like to sell you insurance, like nobody is going to buy insurance from me, like I'm not very trustworthy. But if you interact with somebody that you've seen before and who's kind of bearing the logo of an organization that you know, that sort of increases the credibility of the whole enterprise. Okay, so I told you a little bit about Telangana already and why we like working there, but a few more things that are sort of useful to know. One is that this is like a very prototypical sort of low-ish income agricultural setting. So it's very large, 35 million people in the state. About half of the labor force is in agriculture, but that labor force only produces about 15% of value added. So there's this big mismatch between the number of people working in the sector and like how profitable the sector actually is. We're working largely with smallholder farmers, about a hectare each. They're mostly growing rice, but they're also growing sort of big amounts of cash crops as well. And so you can see substantial fluctuations here in sort of the share of land that's being put into cotton and some of these other crops. And like I said, this is a kind of a major agricultural region in India. This isn't just like one-off farmers. This is like lots of people growing here. And kind of usefully for the research, there's not existing public crop insurance, right? So the thing that we're doing is going to be basically brand new. We're not operating on top of the system where people already have lots of access to insurance. Okay, so this is the timeline of the experiment. The first year, like I said, was last year. So let me go through, there's lots of steps here. So let me try and be clear about what's going on. So the very first thing that happens is that the forecast is issued by the Potsdam Institute for Climate. So they post, excuse me, on their website, here's what the forecast actually says. And then with that information in mind, the very first thing we do is sort of a short baseline survey with farmers. In that survey, we ask farmers what they think is going to happen with the monsoon this coming year. And then at the end of that survey, we provide them with the actual information that the forecast says, or we let them know, hey, you're getting this insurance product. Okay, very importantly is the order of that, right? So we start off by asking them what they think is going to happen, and then we tell them kind of our best information about what's actually going to happen. Then what we do is we go back a few weeks later to do a second round of baseline data collection. In that round, we ask lots of things about crop planting and things like that, but we also ask, now what do you think is going to happen next year, right? And the reason for doing that is we're very interested in understanding how the forecast changes farmers' beliefs. The timing of that is pretty sensitive because we have to make sure that we get those beliefs before the rains actually start, because of course, once the rains have started, then everyone will just tell you what actually happened, right? And so we had to kind of sneak this in pretty quickly. After this second round of baseline surveys were done, then the monsoon actually started. And then our insurance product pays out basically based on how late the rain is. So if the rain is totally on time, you get no insurance payout. If the rain is a little bit late, you get a small payout. A medium amount late, you get a medium payout. A lot late, you get a large payout. Those payouts actually were given to farmers towards the end of the growing season. That was because we wanted to measure the effects of kind of the offer of this insurance product, not the effects of all of a sudden having a bunch of additional cash in hand. And then finally, we do our end line survey sort of towards the end of the harvesting process. The reason we want to do that towards the end of the harvesting process is A, we want to know how much farmers actually harvested, and B, if you try and talk to a farmer while they're trying to harvest their crop, they have zero time for you and no interest. Like, you have to make sure that the surveys are being done in a way that accommodates the growing season schedule, and they have time for you. Right after the harvest is a great time to talk to farmers because they've just done a ton of work and are very happy to like sit down and be not doing stuff in the field for a couple hours. Okay, questions on any of this we've talked through so far? What are some of the social benefits of getting access to this information? For instance, farmers may not use groundwater. Is the study also planning to measure such benefits? Yeah, so the sample was selected such that we are mostly in a place where farmers don't have access to groundwater irrigation. The reason we did that is because the more irrigation you have, the less important the forecast actually is for you, because you can sort of just smooth that risk using that irrigation technology instead. So I think that kind of thing would be potentially interesting to look at, but our context is not super well suited to do that. Is the insurance premium based on the issued forecast? Also a great question. No. So the insurance payout triggers, the timing of when the insurance product pays out, is based on the historical distribution of monsoon onset. So it's not related to anything this year at all. The other piece of this is like, we did not want to be an insurance company. There's a lot of regulations around selling insurance. So what we're actually doing, that I'm calling insurance, a little bit of sleight of hand, what we're actually doing You can think about it, if you'd like, as fully subsidized or free insurance. Another way you can think about that is it's a conditional cash transfer. Okay, so the farmers are actually not paying us at all for the insurance product. We're just paying out to them. The reason we're doing that is because what we're interested in this project is what is the effect of having kind of access to that insurance product on the decisions you make. We're not so interested in kind of how farmers' take up of that insurance would vary with prices. So there's been plenty of other studies that have done that. We don't really want to do that. We just want to compare the effects of the insurance to the effects of the forecast. The easiest way we can do that is to get as many people to take up that insurance product as possible. And so the best way to do that is to just not charge a price at all. Great. Okay. So what are we telling farmers when we go to give them information? There's a lot on this slide. The basic summary here is the script that's over here. So this year's forecast says that the monsoon is likely to arrive between June 11th and June 19th. This year's forecast was actually more detailed than the previous ones have been. So it also then says this is likely to be followed by a dry spell from June 20th to June 29th. And then after June 29th, the continuous monsoon rain is expected. So this actually provides quite a lot of information about what is going to happen this year. We also provide farmers with information about what's happened in the past and where the forecast has been correct or not. So you can see over the last 10 years, the forecast was right 100% of the time. If you backcast this further, we get sort of this 75% information. And we gave this info sheet to farmers to kind of take away with them, so they have some information about what they're getting. Okay. Good news for us is that the forecast was exactly spot on. So I can show you that in two ways. One is kind of this is actually what the forecast was saying. That's what we translated into the graphic. And then over here on the right, I have a very objective source of information, which is our own field research assistant, who on June 13th, right in that forecasted period, sent us a bunch of photos. And you can see his conclusion: the weather is changing, the forecast rocks. Right, so N of 1, great data that the monsoon is happening exactly when we said it was going to happen. It turns out we have better data than that as well. We also collected information from rain gauges that we placed in the local villages to get a good sense of accuracy. But yes, it turns out that the forecast was basically exactly spot on. So that's great. Another thing that turned out to be true this year is that the monsoon was actually quite close to average. Okay, so this was not a very early monsoon nor a very late monsoon, but sort of right in the middle. And interestingly, it turns out that the forecast, which is this dark blue vertical line here, was right in the middle, basically, of what farmers' priors were about the forecast. So these folks to the left are people who thought the monsoon was going to be earlier than it actually was. These folks to the right are people who thought the monsoon was going to be later than it actually was. That's going to turn out to be useful because if you remember, the model that we wrote down suggests that farmers should behave really differently if they're getting good news versus if they're getting bad news. And because we're splitting this distribution right down the middle, we have a bunch of people who are getting good news and a bunch of people who are getting bad news. So that's going to turn out to be sort of empirically helpful. Okay. The insurance product I've mostly already talked about. So the basic idea here is just that the insurance product pays out different amounts depending on how late the monsoon is. Again, that's based on historical averages, not anything about this particular year. So again, we handed out this sort of nice infographic sheet. Obviously, I'm showing you the English language version, so we did in fact translate these before giving them to the farmers, and the enumerator sort of explain what's going on here too when we're providing these products. Okay. Since we've run a randomized trial, the first thing I need to convince you of is that farmers in the control group, farmers in the forecast group, and farmers in the insurance group looks pretty similar at baseline, right? I need to demonstrate that the randomization was actually effective. We didn't mess something up. And yes, in fact, it turns out that 5 PhD economists can sometimes do research properly. We ended up with sort of good balance here across important characteristics. Take up for these products is both quite high. That's sort of unsurprising based on the way that we're handing this out, but also sort of still useful to just show is that the vast majority of farmers who we came and sort of offered these products to did in fact say yes and go ahead and get the information or get the insurance product. Okay, so a couple of results here. The first result is that the forecast does actually move farmers' belief towards the forecast. Okay, that's sort of easiest to see in columns 5 and column 6 here, where we're asking what's the difference between the farmers' posterior belief, so they're late in the pre-season time belief compared to the forecast. And there we see a substantial shift comparing the forecast group to the control group in that difference. And so in particular, what we see is farmers who got the forecast are sort of 10 to 15% closer to the actual forecast in their beliefs about what's going to happen this year relative to the control group. So what that tells us is a couple of things. One is that yes, farmers do seem to be listening to us and do seem to be updating. Two is they're not updating like by a huge crazy amount, right? This isn't like 90% swings one way or the other. I think that's for two main reasons. One is what we were talking about earlier about trust, right? So, this is a brand new piece of information. Yes, it's coming from people you sort of know to some extent, but still like, how much do you actually update based on something you're only seeing for the first time? A little bit questionable. And the second one is this also has to do with the fact that the monsoon was right in the middle of those priors, right? So we don't actually have that much room to move all that many people super far because the average was pretty close to the forecast to begin with. Okay, so we think that this is a pretty big amount of movement conditional on the setup that we have, but it's definitely not, 100% swings here. Okay, so now we want to think about what farmers are doing in response to the forecast and response to insurance. I'm going to show you a bunch of tables that look like this. Sorry for doing this in tables. This is brand new. Normally I would want to do something like this in pictures. It's much more fun, but we're seeing the rough cut here. So the first line of these tables is always going to be the kind of average treatment effects of the forecast relative to the control group. The second line is going to be the average treatment effect of the insurance relative to the control group. So we look at kind of three main outcomes to begin with. The first one is sort of, are you doing any cultivation at all? The second one is how much land is under cultivation. And then the third one is how many plots are you growing? And what we see is kind of interesting. So on the forecast row here, on average, we see basically no effect of the forecast whatsoever. Farmers don't seem to be responding. On the other hand, among the insurance group, we're actually getting quite a lot of movement here. So an additional kind of 1/4 of an acre on a base of 2 1/4 acres of land under cultivation. So insurance folks are doing kind of exactly what we thought that they should be doing, which is kind of making more investments into agriculture. You can also see that by their growing more plots. What starts to become interesting about the forecast is splitting out that average response based on people who are getting bad news, kind of neutral news, and good news, right? We've talked about that model and that split between those two lines. It's sensible that we would get sort of zero effects on average for the forecast because that's going to be a combination of these three groups of people. So the next thing we'll do is split the forecast up between people who are getting bad news, that's at the top here, people who are getting sort of neutral news in the middle, and people who are getting good news. And what we see there is the bad news folks are planting a lot less land. The good news folks are planting a lot more land. And so we get exactly this split that we sort of predicted in the theoretical model. Some of these are, of course, a bit noisy, but at least these sort of generally point in the direction that we think that they should. So that's kind of cool. The other thing we're going to look at sort of from a ex-ante planting perspective is cash cropping. So this column on the left is asking, did you change crops relative to what you sort of had said that you would plant early on in the growing season? And then these other two columns here are indicators for growing cash crops. Again, we see some evidence that the insurance folks are doing more growing of cash crops, and in particular, more growing of cotton, which is like the major cash crop in this setting. But on average, not a ton of response from the forecast. When we split that up into these three buckets, we again see sort of a pattern. All of these are pretty noisy, but we see a pattern consistent with the bad news folks are doing a bit less of these kind of intense cropping. The good news folks are starting to do more. So we see these sort of ordered patterns of bad news do less, neutral, like maybe somewhere in the middle, good news are starting to do more of this agriculture. So that's again consistent with what we sort of predicted to begin with. The next set of things we're going to look at is what happens to just expenditure on a variety of different categories. So expenditure on fertilizers, seeds, irrigation technology. Labor, we're going to split into two categories. So ex-ante labor is going to be prepping your fields for planting and then planting itself. Ex-post labor is going to be any work that you're doing between planting and harvest, and then labor during harvest. And then finally, total expenditures. The insurance folks, again, here are doing a lot more. This is totally consistent with what we've seen in previous insurance settings. And I should mention these effects are pretty big, right? So the control mean here about, I think these ones are in dollars, so about $900. and the total expenditures are going up by about half of that. So actually the insurance is pushing people to do sort of a lot more ag, and that comes largely in the form in this setting of fertilizer and then some of the labor stuff as well. When we split the forecast group up again into these three categories, now we're seeing even more evidence of what we were saying before, which is that there's a lot of negative numbers here in this expenditure category. So people who are getting bad news are pulling out of ag. Whereas once we start to get to the good news, folks, now we're starting to see positives, right? People are doing more and more kind of intensive agriculture, more and more expensive agriculture when they're getting good news from the forecast. We can finally look at some of these ex post outcomes. So now this is sort of after the growing season has sort of shown up. These are by definition going to be noisier because this is not just what you did beforehand, but it's what you did beforehand filtered through kind of all these additional shock to productivity. So I think we want to interpret these as like a little bit more suggestive than we saw in the previous setting. But kind of across the board, we don't see a ton of movement in most of these measures. When we split the forecast up by these three different buckets, we again sort of see patterns that are at least vaguely consistent with responding in one way to bad news, responding in another way to good news. One thing that I'll just kind of flag here, because I think it's pretty interesting, is this fourth column here is a measure of stress. So PHQ is sort of a standard diagnostic tool from psychology that's used to assess mental health. Higher numbers are worse here. So what we see is the farmers who are getting bad news end up being sort of more stressed out. The farmers who are getting good news are getting sort of less stressed by the end of the season. So that's kind of one thing that we think out of this is pretty interesting. Okay, so I told you we were doing a second year of the project. We were pretty excited about that second year. One reason we're pretty excited about that second year is this graph on the left. So what this is showing you is we went and asked these farmers kind of how much did you trust the forecast before you got it or before the monsoon actually arrived. That's the distribution that's here in solid blue. And what you see is like people say, like, yeah, kind of, right? But then interestingly, we went back and asked them, well, how much do you trust the forecast now that the monsoon has been realized? And remember, these farmers got an accurate forecast. And you see that distribution has shifted all the way over to the right? So many more people are saying, yeah, like I actually trust this product quite a lot. So that gives us some confidence that in the second year, we might get even bigger treatment effects, even more responsiveness from this original set of farmers. The other reason, of course, for some optimism is we're working in a place where the monsoon is highly variable. So we're just going to get a different weather draw and we'll be able to see what happens as farmers respond to that second version of the weather. Very quickly, we are starting the second year of the experiment. That second year is going to be a little bit more complicated than the first year was. I want to highlight kind of one tweak that we're making here. So rather than just having a control group, a forecast group, and an insurance group, now we're actually going to split the sample slightly further. And the one that I'm most excited about here is this split in the control group. So what we'll do here is take our control group and split this into two pieces in a randomized way. So now we're going to have a year 2 control that we can use again to benchmark everything. We're going to have a group of people that are getting the forecast for the second year in a row, right? So these are people who got the forecast once, that forecast was accurate, and now they're going to get it again. So we expect that they're going to respond more than they did last year. The challenge with doing a comparison between these forecast year 2 people and those same people last year is I can't just compare how much you responded this year to how much you respond next year because the weather has also changed, right? So if I give you like a very different piece of information, I might expect that you respond differently. It has nothing to do with your previous experience with the forecast. It's just that you have a different weather realization. So what we're going to do instead to test this trust mechanism is use this other half of the control group. This other half of the control group is now going to get the forecast for the first time. So in the second year of the experiment, we'll have a control group that's never gotten any forecasting information. We'll have a group that gets the forecast for the first time this coming year. And we'll have a group that gets the forecast for the second time this coming year. Those groups are all randomized, so we'll be able to give you the causal effect of having the forecast for 2 years compared to having the forecast for 1 year. We're also doing some stuff with insurance, but I'm pretty excited about this sort of second piece. So let me wrap up and leave a little bit of space for questions. What I've shown you is some like super hot off the presses, brand new results from an RCT we've been running on forecast and insurance. We see a few interesting effects. So the first one is that forecasts do seem to shift farmers' beliefs about the monsoon onset towards the forecast. So people listen to us, that's good. The forecast this year was accurate, And the monsoon was slightly later than average, but not crazy off, which gives us sort of this nice split between people who are getting good news and people who are getting bad news. And what we see is that people who got bad news responded to that by reducing their inputs into agriculture, reducing their farming intensity. People who got good news sort of go further in and make more investments, so positive effects on ag. The insurance products ended up being paid out to about half of farmers, but pretty small payouts for most of those people, and consistent with like a large body of previous literature suggests that the insurance causes farmers to expand operations. One thing that I'll also say that I didn't point out earlier is that the farmers who get good news, the degree to which they respond to the forecast actually ends up being pretty similar to the size of the insurance effects. So those insurance effects are quite large. Giving farmers good news seems to have them respond around the same amount. That's pretty cool and suggests that these effects are quite big and potentially have really sort of large positive impacts on welfare. So let me stop there and open for questions. Thanks for listening to me jabber away for a while here on your Wednesday afternoons. Karen, go ahead.
I'm wondering what you're hoping to do if it does show positive results. Are you hoping to go to the existing India Meteorological Department and say, hey, you should really do PIC in your existing forecast?
Yeah, so I think we are maybe 1 or 2 projects away from having like a super large scale interaction with the government. The next project that we'd actually like to do, if these year 1 results kind of continue to be borne out in year 2, is actually an experiment at scale. So what we've been doing so far is working in a pretty small number of villages with a pretty small number of farmers. That's really useful because it gives us a sense of kind of the partial equilibrium response to these forecasts. But of course, you might imagine that the effect of giving one village the forecast would be really different to the effect of giving 50% of villages the forecast. And one reason for that would be price response, right? If what all these guys are doing who get bad news is like, oh, I'm going to pull out of cash crops, then potentially the total quantity of cash crops grown goes way down and the price of that goes way up, right? So then you start to get these kind of general equilibrium price effects. So that's the next thing to test is like, we want to make sure that we're careful about providing government's advice, because it's one thing to say, hey, this worked in sort of a small pilot, but there's in this particular setting, there's good reason to believe that the effects at scale might be quite different. And so we want to make sure we're testing that out before we're going and saying like, yeah, absolutely go all in and do this. Yeah, maybe I'll stop there.
I was wondering because like if it's objectively better information, like why you didn't just like, you know, ask them to use that information in the first place.
Yeah, so I think, you know, a couple of reasons. One is that we wanted to sort of test the extent to which we would be able to get the farmers to respond to new information, right? So it might have been that farmers just ignored us entirely, in which case like that creates additional barriers to scaling. Another reason, just from a practical perspective, is that the government forecast has been so bad for so long that people have gotten really used to just totally ignoring it. And so us working through the government, having the government provide this forecast might have actually done worse than having ICRSAT provide it, because they're sort of used to like, oh, the government information is not so good. The third reason, kind of between us, is that the government has been actually in talks with PIC about their forecast, and so far actually fairly unresponsive to a push to adopt the new forecast. I think about that as just there's a bit of a philosophical difference between the two forecasts. So the best way I can describe this is that the government forecast is using basically a big physics model of the climate and trying to use that to predict the monsoon. The PIC forecast is using essentially big data and a fancy machine learning model of the climate and using that to forecast the monsoon. And so there's a bit of a kind of horse race between these two different types. I think we're moving into the world where people are increasingly interested in the ML-based versions. But, you know, understandably, I think it takes a little while to get people who've been working with the big structural versions to like be willing to adopt the new technology. Yeah, Henry. Oh, you're still muted.
Yeah, can you hear me? Hello.
Yes, go ahead.
Yeah, I would like the model that you use never made mention of coefficient of correlation, coefficient of determination, degree of freedom. So does it mean it's a different model altogether from the usual quantitative models that we know, which is multiple regression and which is the model that most of us are used to. I also want to know whether the community of Telangana always implements recommendations after all these researches.
Yeah, two good questions. So to your first question, yes, kind of getting results from the randomized trial, you can do that in lots of different ways. At the end of the day, we're just comparing average outcomes between the control group and between the forecast group. We're implementing that through kind of a standard simple OLS regression. I'm not showing you, degrees of freedom and all the other stuff, just because there's a lot of numbers in the table already, and I want us to focus on the things that are really important. But yeah, this is totally using completely standard tools. To your second question about Telangana's willingness to adopt new recommendations, I think that depends a lot on what the recommendation is and who's in the government at the time that you're talking to them. So, one thing that I've experienced a lot in fieldwork in India is that, and this would be true here as well, I'm sure, the particular bureaucrats in charge of the thing that you're working on matter a lot for how kind of information is received, right? So I'm working in a very different setting in the state of Madhya Pradesh with some of the electric utilities there. And in electricity in India, there's a lot of bureaucrat turnover over time as new elections happen and just people are sort of cycling through the government. What you find is that some people are highly responsive and other people not so much. So you sort of hope that at the time you kind of present the research, you also have receptive folks at the back end. I think one thing that's nice about coming from UChicago is we're increasingly building a credible brand in India. So we have an office in Delhi that kind of belongs to the university as sort of a mini campus. There's a bunch of Harris alums that are from India, many of whom have returned home and are sort of now sort of filling out the policy ranks there. And so I think, the long game here is that over time, the kind of Indian policy establishment becomes more and more receptive to this type of research. But of course, it's going to be a little bit of a roll of the dice of who you happen to be talking to at any given time.
Interesting. Thank you very much.
Great.
Yeah.
All right. Anything else I can tell you about Harris more broadly?
There's a question in the chat, I think. I'm not sure if it's addressed.
Oh, sorry.
Michael O'Rourke's question.
Yes, since the insurance is being offered for free, could its effect on agricultural intensity be acting more like a partial subsidy than accounting for downside risk? Yeah, so I think let me say it this way. A good way to test for that would be looking at effects basically on, well, so two things. One is we can test for that directly by looking at effects on who actually got payouts versus who didn't, right? Because not everybody actually ends up getting a payout in the study. But the other thing I'll say is that most of the results that I was showing you were sort of ex ante, right? Things that farmers did before the rain actually started or very early on in the growing season. So it's sort of unlikely that those effects are going to be driven by a cash payout, because that cash payout at the kind of best case is happening in like October, November. So it's definitely not the case that these folks have that cash on hand when they're making those early investments. Yes, of course, it's going to be true that like at the end of the day, the people who experience the bad state of the world do get a large cash payout, but it's not like they're all of a sudden sort of sitting on a cash transfer that happens right away when they're making these decisions. So I think the kind of difference in timing between when we're measuring or when we're asking them about what they're doing and when the money comes in helps to disentangle those two things. Michael.
Yeah.
Oh, sorry, Mitchell. Sorry, I can't read. You're small on my screen.
It happens. Yeah, I was wondering how, this is kind of a technical question, but how did you make the decision on like how large the payouts would be? Is it like in line with like Western equivalents of like insurance payouts, or yeah, I guess I'm just curious about
Yeah,
that.
no, good question. And I have a like very boring technocratic answer, which is it was totally budget determined, right? So the insurance is the most expensive arm of our experiment. The reason for that is because, again, since we are not an insurance company, we actually budgeted to pay out the full amount to every farmer, right? Because we didn't want to be caught in a case where it turned out the rain was really late, and then we had promised all these people money that we didn't have. So, you know, that turned out to be the big limiting factor, is just how much can we afford to pay out? It turns out that we could afford to pay out actually a fair amount. So the kind of high payout amount is something like, on average, about 20 or 30% of farmers' revenues. So that's actually a pretty big share of the money. One of the things that was the result of it being a fairly average monsoon is that was sort of lucky for us, because it meant we didn't have to do nearly as many of those expensive payouts. So we could put a lot of that money to the end line survey and sort of save on having to do future fundraising. But yeah, we wanted to make sure that we had the cash on hand if we needed it to pay out everybody at the max. And so that was kind of the major constraint there.
Cool, thank you.
Professor, I think that was everyone's questions, and you gave us the extra time to get through all of them. So I appreciate the extra additional time. Everybody, I just want to thank you for coming, and thank you for such engaging questions. Professor, also thank you for sharing some new research and information with us. That's always, we were slacking back and forth in our team chat over here on the student recruitment side of, you know, breaking news research from Professor Burlig. You love to see it. So thank you so much for sharing that. Any just final pieces of advice for students as they're thinking about graduate school, Professor?
Harris is a great place to be. You know, I think that our reputation as like one of the more quantitative MPP programs is sort of well deserved. And I think, you know, one thing that I really appreciate about our MPP students is we have a bunch of people coming in with a broad range of backgrounds. That means some people coming straight from college, some people who worked either in the public sector or in the private sector for a few years coming in. I think, you know, maybe the best advice I can give you is, yes, it's great to come to a policy school and learn from your professors, but I think most of the learning actually happens from your peers and from each other. So it's definitely worth making investments in, you know, making friends and getting to know your cohort, because that will pay dividends going into the future.
Well, again, Professor, great advice for students. I always say nobody ever gets through graduate school. Nobody gets through Harris alone. You've got to make those friendships and make that network. So that's great advice to hear from you. And again, very much appreciate your time and everyone's time today. Have a good rest of your day.
Great. Thanks, guys. Nice to meet you.